In this video, we will integrate AWS CodeBuild and AWS CodePipeline with GitHub repository for continuous build and deployment. AWS CodeBuild will be triggered whenever a pull request is created. AWS CodePipeline will be triggered once the code is merged to master. Instead of clicking through AWS console, we will write CloudFormation template, which allows you to build and rebuild your infrastructure for multiple projects without having to perform manual actions. Let's get started. First, we will generate a personal access token in GitHub, which will be used for authentication when using the GitHub API. From the drop-down menu in GitHub profile, go to Settings, Developer Settings, Personal Access Tokens. Click on Generate New Token and add a description such as AWS or anything that helps you identify this token in future. We will be creating webhooks in the repository, therefore we need to select the repo and admin repo_hook permission for the token. This token cannot be seen later, so let's copy it and save it in AWS Secrets Manager right away. In AWS console, search for Secrets Manager, then click on Store a new secret. For the secret type, we will select other types of secret. In key value pairs, let's call it GitHub Access Token and paste the token that was copied earlier. Click on Next. Give it a name. We will call it GitHub_access. Click on Next again. This secret can be used in CloudFormation template as well as using AWS SDK. Here are the sample codes for reference. Go ahead and click on Store. Now we have generated a GitHub personal access token and saved it to AWS Secrets Manager. Now let's move on to creating a new GitHub repository, which we will use for the CI/CD pipeline. Let's call it GitHub AWS CI/CD and keep it public. Initialize with a README and let it add a gitignore for Python for now. To clone this repository, click on the code drop-down and select the HTTPS URL or use SSH. For now, I'll go with HTTPS URL. Run the git clone command. Go to the project root. I will be using the Sublime Text IDE. Feel free to use any IDE you prefer. Let's create a new file and call it buildspec.yaml. The buildspec file will have the build commands and settings that the AWS CodeBuild uses to run the build. Search for AWS buildspec reference in Google and go to AWS Docs and click on buildspec example. We will copy the example build spec and paste it to the YAML file. We can remove everything except the build phase. The finally block and the Maven command can also be removed. In this example, we will keep the steps simple, but for your project, you can have the project specific commands to run builds and tests here. Now let's commit and then push these changes to GitHub repo. You might have to configure your username and email before creating a commit. Run the git add command, git commit, give it a message, and run git push to the master branch. You should see the buildspec.yaml in your GitHub repo now. Next, let's get started with creating the CloudFormation template to create the CodeBuild project, which runs this buildspec.yaml. In AWS console, search for CloudFormation. Click on Create Stack with New Resources. We will create this template in a designer. So click on Create Template in Designer. Go to the Template tab, and then let's switch to YAML format. In the resource types, search for CodeBuild, and then drag and drop the CodeBuild project. We can remove all the metadata. And also let's change the resource name to CodeBuild project. Let's give the project a name. We will reference to the AWS stack name. It's a pseudo parameter and returns the name of the stack as specified when you create the CloudFormation stack. And we will also need a service role for the CodeBuild project. So that's the IAM permissions this CodeBuild project will require to run your builds. To know which all properties are required to be defined in a CloudFormation template, go to the CloudFormation document and search for required parameters. You should know those parameters from here. Let's create the IAM role and call it CodeBuild service role. So the type would be AWS IAM role. For the properties, let's start by defining the assume role policy document. We'll keep the version 2012-10-17. The policy required for the IAM role can be found in AWS CodeBuild Advanced Setup documentation. Here you can see the policy is broken down into two separate policies. Like one is the assume role policy and then the role policy. For the role policy, we need permission to write logs to CloudWatch. And there are other permissions as well. But for now, let's copy the assume role policy and then paste it into our template. So it's easier to switch to JSON and then paste the reference as you get in the documentation. Next, let's define the role policies. So it's going to be a list of policies. So we'll start by policy name. We'll call it root. And the policy document, we will reference from the documentation. Instead of fixing the indent in JSON, we can just switch to YAML. So that does the cleanup for us. Now in the CodeBuild project, let's reference to the service role created above. Then we need to define the source and artifacts. In source, we will define the GitHub location and authentication configuration. Set the type to GitHub. Location will be the GitHub HTTPS URL. Let's also define the build spec file name. By default, it uses buildspec.yaml. Next, let's define the authentication type to be OAuth. Then the resource would be a source credential resource. Let's call it CodeBuild source credential. And the type would be AWS CodeBuild source credential. The properties you need to define are auth type. It would be personal access token. The server type would be GitHub. And the token itself, we will have to refer that from the secrets manager. And this is the syntax for it. Let's add a reference to the source credential resource. We will set artifacts as no artifacts for now. This specifies the output settings for the artifacts generated from CodeBuild. For now, we don't care about it. Next, we define the triggers. This is the event that would start CodeBuild projects. For now, we will use the webhook from GitHub, and we are using filter groups for it. The webhook event should match pull request created or pull request updated, and the base ref, which filters on the git reference name of destination branch, in this case master, should both match before the CodeBuild project is triggered. Since we are using GitHub for source repository, the permission for code commit is no longer required, so we can remove that from the CodeBuild IAM policy. We will leave the S3 bucket permissions intact. Now let's run a quick validation. Click on that checkbox there. Looks like we have some formatting issues. Let's fix that. Let's try it again. Okay, there's one more error. Okay, this one here should be gate attribute instead of reference because we are getting the ARN attribute for it. Okay, it looks good now. We also need to define the environment that this CodeBuild project is going to run on. For the type, we will put Linux container. For the compute type, build general 1 small is good enough. For the image, we will reference to the provided container images. If you go to the documentation, you will find the Docker images provided. There, we will select the standard 4.0, which is Ubuntu 18.04 environment. Let's copy this and then create a new file into our repository and then add this as a pipeline.yaml file. There's a typo here. Let's change that secret manager to secrets manager and do the same here. Now click on the cloud button there. That would create a stack. So we'll use the defaults, whatever is provided. Click on next and give it a stack name. GitHub AWS CI/CD is fine. Click on next. And it's going to create some IAM resources. So this is some warning for it. Just click on this checkbox and then click on create stack. You can refresh the events to see the progress. And there you will see a CodeBuild project, a CodeBuild service role, and the source credential created. So let's go to the CodeBuild project. And there is our CodeBuild project. The primary repository, it's referencing to the GitHub repo. And if you look at the build details, here's the Webhook event detail. You can click on this URL to see the Webhook configuration that was added to GitHub. Now let's create a develop branch. And then we will commit the pipeline.yaml file we just created. For the commit message, you can put anything. I'll call it CodeBuild CloudFormation template initial commit. Now git push origin develop so that it goes to the develop branch. Next, you can create a pull request from the develop branch to master to validate our webhook. In the repo, you can click on this compare and pull request button. There you'll see the base branch is master and then request coming from develop, and it shows it's able to merge. So just click on create pull request. Even though it says this continuous integration has not been set up, it's referring to its own native GitHub Actions setup, but we will be using CodeBuild. So if you give it a second, a link to the CodeBuild project should appear. So that there is our CodeBuild project running in AWS. So if we click on the details link, it should take you to the CodeBuild project that's running, triggered by the pull request. Here's our commands, and everything looks good. And you can merge this request, select squash and merge, and then confirm squash and merge. So the pull request has been closed, and you've validated the pull request by running a CodeBuild project, which could have been a build and test step for your application. Next, let's add some branch protection rule so that the pull request cannot be merged unless the CodeBuild project is successfully completed. Add the branch name pattern to master, and then we'll say it will require pull request status check to pass before merging. So since we already ran the pull request once, you will see this AWS CodeBuild reference here. So if you have not created a pull request or have not run this CodeBuild once, this option won't appear. So run that once and then create the branch protection rule. Let's check out master branch and pull the changes after the merge. Okay, we can go back to develop. Since the commit versions have diverged, we cannot do a direct pull from the master. We need to run a rebase. So run git rebase from the master. That should set the log history to match the origin master, and your commits should be the same. Let's clean up this CloudFormation template a little bit. So we'll add some description. Also, we want this same template to work for multiple GitHub repository. Let's add some parameters. We'll add GitHub owner, which would be a type string. And for the allowed patterns, we want to put all the uppercase and lowercase characters and some numbers. Let's copy it and create another parameter for GitHub repository name. The type and allowed pattern would be the same. For the GitHub owner, since the organization name would be the same, you can set it to a default value. Also, if you want to, you can add a parameter for GitHub branch. For now, we'll just default it to master, but you have option to change if needed. So let's change this type to sub and then replace that owner name with the parameter reference. Same with the repository name and also the branch reference. And we also want to add the git request reopened event. Let's try to deploy these changes. We will copy this, go to the AWS console, CloudFormation, select the stack, click on update, and then let's select edit template in designer, view in designer, and then replace the template with the one that we just copied, validate it. Looks like we have a typo again, so the default should be a capital D. Let's validate again, and then click on this create stack button, leave everything default, click on next, and now we have parameters to set. So we'll give our GitHub repository name and click on next, acknowledge it, and then update stack. Wait for the update to complete. Okay, that looks good. So everything went fine. And there you should see our parameter in the template as well as the parameters tab. Let's save these changes. We'll create a new commit and then open a pull request so that we can validate our branch protection rules. When you push to the develop branch this time, you have to pass a --force flag since the commits do not match, and it should do a forced update. So now let's go to GitHub and then look into our commits. The histories look good. And let's open a pull request to the master branch. From develop, able to merge, so everything looks good. Click on create pull request. This time the squash and merge button, that's disabled, but since you are an administrator, you might see that button. But for if you are not an administrator, since we added that branch protection rule, you should not be able to merge the change unless the CodeBuild project successfully completes. So let's wait for this project to complete. We can also go to AWS to look into the logs. Looks like it's done. And now it's all good and we can merge our changes. So this completes the first part of the setup where we are running a CodeBuild project whenever there is a pull request to validate that the code changes do compile, successfully build, and then we can also run some tests we want to before we merge that source code into our master branch. Now let's create the code pipeline which will be triggered when pull requests are merged to the master branch. Create a resource in CloudFormation template for AWS CodePipeline. The properties we need to define are the name of the pipeline, which can be set to the stack name. service role for CodePipeline. We can copy the CodeBuild service role and change the service to codepipeline.amazonaws.com. We can leave everything else the same. Artifact store, which is the S3 bucket where artifacts for the pipeline are stored. Create the S3 bucket resource. Make sure that the versioning is enabled. The pipeline can have multiple stages. First one will be the source stage. A stage can then have multiple actions. Here the action provider is GitHub. Refer to the parameters for GitHub owner, repository, and branch for the configurations. To trigger the pipeline, we can either use poll for source changes or webhooks. Set poll for source changes to false. In this case, GitHub webhook will be used. To be able to clone the repo, we need to provide the OAuth token. The token was saved in Secrets Manager. Let's use that. The source action should have output artifacts defined, which will have the source code from GitHub. In the next stage, we will build the application using CodeBuild. Here, the provider for the action is CodeBuild, and in configuration, we need a CodeBuild project name. Since we already created a CodeBuild project to run builds triggered by the pull request, we can use the same project here. The output artifact for this action would be the build output, and then the input artifact would be the source code that we got from previous action. We now need a CodePipeline webhook resource, which will create webhook in GitHub, which will trigger this pipeline whenever there is merge to master branch. Set authentication to GitHub HMAC and provide the token from the Secrets Manager. Register with third party will be set to true. For the filters, use JSON path where .refs should have refs, heads, branch, and repository name should match the provided repository name. The target pipeline will be the CodePipeline project, and target action is the source action. It also needs reference to the CodePipeline version. Since we will be running the CodeBuild project from pipeline, the CodePipeline service role must have permission to start CodeBuild projects. You can refer to the documentation provided for CodeBuild service role. Let's update the CodePipeline service role with that. Copy and paste the changes we made in this template to local file. Validate the template and update the stack. Leave everything as it is and click on Next. Acknowledge the I am warning and wait for stack update to complete. In the list of resources, now we have the CodePipeline, artifact store, service role, and the webhook created. If we go to the repository settings in GitHub, in the webhooks page, we should see the second webhook added. In the CodePipeline, it should have already triggered the first run when it got created. We see the source stage was successful and we are in the build stage, which is running the CodeBuild project. We can click on details to go to the CodeBuild project. Looks like the build was successful. We can now commit the changes we made to the CloudFormation template, which will also help validate the entire flow. Before you push the commit, check out master branch, pull from origin master, switch to develop branch, and rebase from master. Then when you do a push, add a -- force option. That way you will not have commit history conflicts. In GitHub, create a pull request to the master branch. You should see the checks for pull request running the CodeBuild project. Once complete, squash and merge. Once merged, If you go to the code pipeline, you should see the source action was triggered, and then the build is currently running. That validates our setup to trigger code pipeline when pull requests are merged to master branch. So far, we just did the build stage. Now we will create the deployment stages. To separate the build commands with deployment commands, we will create a separate CodeBuild specification file and name it deploy-spec.yaml. We can copy the content from build-spec.yaml. You can adjust these commands to have the commands for deploying your application. For now, I'll just change the echo statements to say deploy instead of build. When deploying application to various environment, the configurations will be specific to that environment. Let's add environment variable env_name and set default to dev. This environment variable can be overwritten by the CodeBuild projects. Let's also add a line to print the environment variable. In the code pipeline, add a stage called dev, and the action name will be deploy. We will be running a CodeBuild project, so rest of the configuration is the same as the build stage. Only change will be the CodeBuild project. We cannot override CodeBuild project's configuration from code pipeline definition, so we need to create a separate CodeBuild project with the configurations that fits the dev deployment. Copy the CodeBuild project, remove the webhook triggers, change the build spec to deploy-spec.yaml. Also, the source type and artifacts will be code pipeline. Then we can add the environment variable required to deploy the application to dev environment. In this case, we just need the env_name variable. Update the resource name. We can add deploy dev to the resource name. Similarly, copy and paste to create CodeBuild project for QA deployment. The environment image is being repeated in all CodeBuild projects, so it's a good idea to change that to a CloudFormation parameter. Now copy and paste one more time to create CodeBuild project for prod deployment. Change the environment variables. Also change the CodeBuild project names to deploy-dev, deploy-qa, and deploy-prod. In these CodeBuild projects, the build spec should be set to deploy-spec.yaml. In the build-spec.yaml file, you must now add artifacts section, which defines the list of files that you want to include in the package created after build. It could be the target dest directory for your project, but for now we will just include all the files. Now let's create the additional stages. In this dev stage, you no longer need the output artifacts. We just use the output from the build stage. The QA and prod stages will be exactly same as dev. Only difference is the CodeBuild project. We want to be able to approve changes in QA or testing environment before we deploy to prod. That can be done by adding a approval action to the QA stage. Add a run order to these actions so that the code build runs first, then the approval runs once completed, or else they will run parallelly. That's pretty much it. Let's update our CloudFormation stack. If you don't want to go through the console to update stack, we can also use the AWS CLI to update the stack. You must have a user created and the security credentials for the user to run AWS CLI commands. Once you create the user and have the credentials for the user, install AWS CLI, then run AWS configure to create a default profile. This is the command to deploy the CloudFormation stack using AWS CLI. Notice that we need capability IAM and parameter overrides to pass the non-default parameters. Run the command and wait for stack update to complete. Once completed, the code pipeline should now have source, build, dev, QA, and prod stages, with manual approval required in QA stage before deploying to prod. You can either commit the changes made to the template and go through the entire flow, or just click on Release Change to rerun the code pipeline with previous commit. Let's commit the change to the repo and create pull request to validate the entire flow. Merge the request. We can see the pipeline was triggered and currently running the QA deployment. Once completed, it will wait for manual approval. Once approved, it deploys to production. That completes the tutorial. Feel free to ask any questions you have in the comments. Thank you.